We're going to talk today about reference angles. Reference angles are acute angles that go between 0 and 90. And then they are made between the coterminal side and the x-axis. So it is very important that here we see that our comparison is the x-axis, and that's going to be very, very easy. So what we want to compare it with is this one right here. So this one is going to be the important one. So before we go into anything else, remember that we have 4 quadrants, and the 4 quadrants are going to give us different reference angles. So for example, if I'm in quadrant 1 and I have this angle right here, in quadrant 1, the reference angle equals the angle. Because we are between 0 and 90, we're going to have exactly that, right? If we go to quadrant 2, and in quadrant 2, we have this angle right here, and this angle, we can name it theta, but in blue. In quadrant 2, my reference angle is going to be this angle right here. This angle right here, it's going to be exactly the same as the other one. So in quadrant 2, the reference angle is going to be 180 minus my angle. So it's going to be all this one minus this one. So I can have exactly this measurement right here. So we have 180. Remember that 180 is also pi. So we have pi minus my angle. If we are in quadrant 3, so for quadrant 3, we have this one right here, right? So for quadrant 3, we have all this angle. So it's going to be theta, but in yellow. So the reference angle is between the horizontal and my angle, right? So if we go all the way over there, so in quadrant 3, we have the reference angle is going to be the angle minus pi, because we're going to count all of this, and then we're going to subtract pi, or 180. So theta minus 180. And in the 4th quadrant, so in the 4th quadrant, if I have an angle like this, my reference angle is going to be this one, right? And my actual angle is going to be this one. So in quadrant 4, I'm going to have my reference angle is going to be 360 minus the angle, or 2 pi minus the angle. So these formulas are going to come in handy for when we want to work with these types of angles, right? Remember that the reference angle always goes between 0 and 90, and we are always comparing it to the x-axis or the horizontal. So with this in mind, let's do some exercises. The first one that we're going to do them in degrees, and the other ones we're going to do them in radians. So first in degrees. So if I have the angle 210, I want to know what my reference angle is. So first of all, I want to identify, so I have 0, 90, 180, and 270. So if I have 210, that means that I'm over here, right? So this angle is going to be 210. So this one is in quadrant 3, right? So my reference angle is going to be this one right here. So what am I going to do? In quadrant 3, the reference angle is equal to the angle minus 180. So in this case, the angle measures 210 minus 180. I get a reference angle of 30 degrees. So this angle, this one that I have here is 30 degrees. So that would be my reference angle. Let's do another one. So for the other one, I have 60 degrees. So 60 degrees, and let me do it in another color. No, let me do it like this. 60 degrees. So 60 degrees, without doing so many things, I have 0 and 90. 60 is around here. So 60 degrees. So if you see in quadrant 1, it's very easy because my reference angle, it's actually the angle, right? So the reference angle equals the angle. So the angle is 60, so my reference angle is also 60. All right? So now let's do another one. So I have minus 120 degrees. So remember that negative angles are measured clockwise, right? So minus 120 is going to come like this. This is minus 120. So if you see minus 120 has a positive coterminal angle, so it's going to come like this, a positive coterminal angle of 240. So we're going to use the positive one, 240, and I see that 240 is in quadrant 3, right? This is quadrant 3. So for quadrant 3, the reference angle equals the angle minus 180. So my angle is 240 minus 180 gives me an angle of 60 degrees, a reference angle of 60 degrees. So if I just take this angle from the horizontal, I have 60 degrees. By graphing it, you can see that you can do it in an easier way, right? So we need only 60 more degrees to get to 180. You can also do it just like by inspection. But if you want to be super specific with your process, you can do it the way that I showed you. So the last one that we're going to do with degrees is 300. So 300 degrees is in quadrant 4. It's somewhere over here. So we have 300 degrees. I have 270. And I have 360, right? Which is the complete cycle. So if I'm in quadrant 4, the reference angle is going to be 360 minus the angle. In this case, the angle is 300. So my reference angle is 60 degrees. Right? So exactly the same process we can do when we're doing radians, but let's check it out. So if I have, I don't know, 7 pi over 6, so we have A, B, C, D, E, 7 pi over 6, 7 pi over 6, so this is 0, this is pi over 2, this is pi, this is 3 pi over 2. 7 pi over 6 is going to be here, right? Because remember that pi would be 6 pi over 6, and 7 pi over 6 is just a little bit more, right? So 7 pi over 6 comes all the way over here. 7 pi over 6. It's in quadrant 3. So we said for quadrant 3, my reference angle is going to be the angle minus pi. So my angle is 7 pi over 6 minus pi, which is pi over 6, right? So my reference angle from the horizontal to the coterminal side is going to be pi over 6. Now, for the other one, I have 11 pi over 6. So 11 pi over 6 is in quadrant 4, right? So it's going to be here, 11 pi over 6. This is 2 pi. This is 3 pi over 2. And it's going to be there because 2 pi is also 12 pi over 6. It's exactly the same, right? So it is in quadrant 4. In quadrant 4, my reference angle is 2 pi minus the angle. So in this case is 2 pi minus 11 pi over 6, which gives me, again, pi over 6, because it's the same length, pi over 6, right? So now for the last two, and let's see if we get another quadrant. We have 5 pi over 3. So 5 pi over 3 is, this is pi, this is 3 pi over 2. Pi is also 3 pi over 3. So 5 pi over 3, this is 2 pi, which is 6 pi over 3. So 5 pi over 3 should be over here. So 5 pi over 3. So now if I'm in quadrant 4, my reference angle is going to be 2 pi minus the angle. So 2 pi minus 5 pi over 3. This gives me a reference angle of pi over 3. For example, in 5 pi over 3, it's not clear, like where should I put it if you are not very familiar with the unit circle. And if you do it in quadrant 3, and if we do quadrant 3, so quadrant 3, and this is a parenthesis, right? I mean, this is incorrect, but I want you to see how incorrect looks, right? So if we have quadrant 3, the reference angle equals the angle minus pi. So if the angle is 5 pi over 3 minus pi, this is 2 pi. This is 2 pi over 3, right? Remember that reference angles need to be between 0 and 90, or 0, and in this case, 90 is pi over 2. And pi over 2, 2 pi over 3 is larger than pi over 2. So that gives you an idea that your angle is not correct. It needs to be an acute angle between 0 and pi over 2. So that's how you can see that it is not in quadrant 3. It's actually in quadrant 4.